In this video, we will be discussing section 13.2, and the goal of this section is to use general angles that may be measured in radians. So this is going to be the first time that you have seen radian measures. So instead of using degrees like 30, 45, 60, 180 degrees, we're going to use them in radians, which is just a different type of measurement. Alright, so to start off here, we have a couple of vocabulary words. So feel free to pause the screen, get some of those definitions down. You don't have to write them word for word. You just need to know what they are in general, because I will be using them throughout this video. Alright, so the first part of this lesson is drawing an angle in standard position. So in a coordinate plane, an angle can be formed by fixing one ray, called the initial side, and rotating the other ray, called the terminal side. So initial is where you begin and terminal is where you end, about a vertex, and that vertex is going to be at the origin. So right here, this is my initial side, and that's going to lie on your x-axis. The vertex is going to be at the origin 0, 0, and wherever the terminal side is, you are always going to have a point starting at the initial side, and then the arrow tells you whether the angle is going to be positive or negative. So since I am rotating counterclockwise here, counterclockwise is going to be positive. And if instead my angle were starting on my initial side and then going to a terminal side here, and the arrow was going clockwise, the angle would be negative. Alright, so just keep those small notes in mind. Those aren't necessarily in your book. Alright, so let's go ahead and look at a whole bunch of examples. Draw an angle with a given measure in standard position, so 240 degrees. Alright, so my initial side is always going to be right there on the x-axis, and then if I were to go 240 degrees, I would go to right here, which is 180, and then I'd have to go 60 more degrees past 180 for the 240. Alright, example 1b, draw an angle with a given measure in standard position of 500 degrees. So 500 degrees, I will actually be going past 360. So starting at my initial side here, if I trace along here and I get all the way back to my starting point, that's 360 degrees, so I'd have to go an additional 140 degrees to my terminal side. Example 1c, negative 50 degrees. So as I discussed all the way in the beginning there, a negative angle would go clockwise instead of counterclockwise. So because it is negative, the terminal side is 50 degrees clockwise. So here's my initial side. It is always my initial side, and it's going negative 50 degrees here. Alright, and if I were to meet right back at the same terminal side, however going the other way, it would be 310 degrees, right? So negative 50 and 310 degrees have the exact same terminal side. So find one positive and one negative angle that are coterminal. So if I had looked at the definition for coterminal, what that means is they have the exact same terminal side, just like I drew in on the last example. So how we accomplish this is by adding or subtracting 360 degrees. So there are many angles. You can keep adding and keep subtracting 360 degrees. when they ask you to do this, typically you just give the lowest values possible. Alright, so I'm going to add 360 degrees to negative 45 and get positive 315. And then I'm going to subtract 360 degrees and get negative 405. So if I were to draw those, they would end at the exact same terminal side here. So negative 45 degrees would start here and end there. A positive 315 degrees would start at the same point, and a negative 405 would go negative 45 and then an additional 360 around. Alright, so if I were to do this for 395, I would subtract 360 degrees and get 35. And then if I were to find a negative one, I would not only have to subtract 360 degrees once, I'd have to subtract it again. So we're always looking for our lowest values there. So in this case, I subtracted both times instead of adding once and then subtracting 360 degrees. So why don't you go ahead, pause the video, and try out these guided practice examples. For 65 degrees, if you were to draw the angle, your initial side is always going to be on that x-axis, and it is positive, so it will be going counterclockwise here. And a couple of coterminal angles would be 425 degrees and negative 295. Alright, next guided practice, 230 degrees. So 230 degrees, if I were to plot that, it's positive, so it's going to go past that 180 degree mark, and it's going to go 50 degrees past that. So that's 230. And then the coterminal angles would be 590 and negative 130. If you kept adding or subtracting 360, your degree measurements for the coterminal angles might be different. Does not mean that they are incorrect. Alright, 300 degrees. 300 degrees is going to go past 90, 180, 270, and then an additional 30 degrees past 270. And the coterminal angles, the lowest ones would be 660 degrees and negative 60 degrees, which brings us to our last guided practice here, 740. And if I were to draw that one, this one's a bit tricky. So I would start and I'd go a full 360 degrees here. And then an additional 360 degrees would only get me to 720. So I'd have to go, that'd be 720 degrees, an additional 20 past 720. And some coterminal angles would be 20 degrees and negative 340. Alright, so converting between degrees and radians, since we aren't always going to be using degrees here, especially when you get into pre-calculus, you will be using radians. So in order to convert degrees to radians, you need to multiply by pi radians over 180. And if you were to convert radians to degrees, you would multiply by the reciprocal, which is 180 over pi radians. So it's just a simple multiplication factor. And what that means is, in terms of a circle, pi is 180 degrees. So if I were to draw out, here is 0, or 360 degrees. Alright, this is 90 degrees, this is 180 degrees, and this is 270. If I were to draw out my angle measurements here, this is pi. That means this would be 2 pi. This would be half of pi, so pi over 2. And this would be 3 pi over 2. Alright, and we're going to be using that sort of picture a lot in the future. Alright, so looking at an example here, convert 125 degrees to radians, and then convert negative pi over 12 radians to degrees. So in order to do this, I need to multiply by pi over 180 degrees. And I would get 25 pi over 360, or 25 pi over 336. You did originally have 125 over 180, but you did reduce it. And part B here is similar, except you are multiplying by the reciprocal. And if you cancel out your pi's here, and you get negative 180 over pi, or over 12, which is negative 15 degrees. Alright, so let's go ahead and do a couple of guided practice. See if you can do it on your own. Pause the video and get the solutions that we get. 135 degrees should convert to 3 pi over 4. Negative 50 degrees should convert to negative 5 pi over 18. 5 pi over 4 should convert to 225 degrees. Pi over 10 should convert to 18 degrees. And looking at example 4, this is a multi-step problem. A softball field forms a sector. Hopefully you remember this vocabulary word from geometry. I'll go ahead and highlight it. A sector is just a pie piece. Alright, it is a portion of an area of a circle. With the dimensions shown, find the length of the outfield fence and the area of the field. So step 1, I need to convert the measure of the central angle to radians. Alright, so it is 90 degrees. That is my central angle. So when I convert it to radians, I get pi over 2. And step 2, find the arc length and the area of the sector. So there are a couple formulas in your book that we're going to need. And here those formulas are on page 861. You need to make sure to get these arc length and area formulas into your notebooks. So S equals r theta and A equals 1/2 r squared theta. Alright, so it's always helpful to have formulas written down as soon as you see what it's looking for. So arc length, S equals r times theta, so I have 180 degrees times pi over 2, which gives me 90 pi, or approximately 283 feet. And then the area, making sure that I have 180 feet in for r, which is my radius, and theta, which is my central angle. I have pi over 2 in for theta, and I multiplied out using my order of operations correctly, and I get 8,100 pi radians exactly, and that gives me 25,400 feet squared. So the answer, the length of the outside fence, is that chunk of the circumference of the circle is 283 feet, and the area of that field is 25,400 square feet. Alright, so guided practice. What if in example 4, estimate the length of the outfield fence and the area if the outfield fence is 220 feet from home plate instead of that 180. So go ahead and use the same formulas, but instead of 180, you're using 220. In the answer, the length of the outfield fence should be about 346 feet, and the area of the field is about 38,013 square feet. Alright, if you guys have any questions, always feel free to email me or send me a message on Google Classroom. Good luck!